Hello everyone. Now let us start the next type of problem. It is find the reflection at the free end and slope at A. So they have asked you to find the deflection at the free end and slope at A. So it's a overhanging beam and wherein EI is constant. Okay. So here ABC is overhanging beam wherein there is a point load at C. So they have asked us to find the reflection at the free end only, that is at point C. Now there is already a load here, so no need to apply any dummy load because this is the load vertical. To find the vertical reflection, we already have a point load here. Now, but we have the formula of Castigliano's theorem. That means you have to have P in it. So what we'll do here is for the same 6 kilonewton, instead of writing 6 kilonewton, we'll write it as P. Okay, so let P be 6 kilonewton. So I've shown it here. P is equal to 6 kilonewton. So as usual, when you're solving this, we'll take it as P. In the end, we'll substitute the value of P. So now P is equal to 6 kilonewton. Okay, then we'll find the reactions. Okay, now to find these reactions, first find see that is moment about A. We'll take moment about A. We have to find deflection at the free end. It means we have to find delta C. So to find this delta C at this point C, so we'll find the reactions, that is moment about A. So moment about A is equal to same thing as usual, RA, that is RB, okay, RB into this distance 12 is equal to 6 into 24. RB is going anti-clockwise and P, that is 6 kilonewton. Now we'll not take it as 6, we'll take it as P here. Okay, P into completed distance, that is 16. Okay, so RB into 12 is equal to 16P. So then solve the value of find out the value of RB. So RB is equal to 4 by 3P. Okay, 4 by 3P. Next, we already have the next equation, that is summation V is equal to 0. Summation V is equal to RA plus RB is equal to P. So RA plus RB is equal to only one load, vertical load. So it is P. So now RA is equal to P minus, so this RB value. Okay, P minus 4 by 3 times P. It's like 1 minus 4 by 3. It is nothing but minus 1/3 of P. Okay, now see here, RA, actually the sign is minus. Minus means it should be opposite. So what I'll do here is, I'll just write RA, I'll show upward only the direction, but in the value I'll show it as minus P by 3. Okay, in the value I'll show minus P by 3. So RA is minus P by 3, RB is 4 by 3 P. Okay, next as usual, to find the deflection, take the plot the table. Okay, draw the table here. So portion AB, BC. Okay, then origin. For AB, origin is A. For BC, origin is C. Always from the ends you should consider. Then limit for AB, 0 to B, 0 to B, it is 0 to 12. And limit for CB, it is 0 to 4 at this distance. Okay, then moment mx. Okay, so I'll cut the section. So in AB, whichever section I'm considering, whichever portion I'm considering, that portion I have to cut the section, the left side. So left side only one load. It is minus P by 3 into x. So I've written here minus P by 3 into x. Similarly, in this portion, okay, right side only one load. Look at the section, which is P into x. So I've written here P into x. So why this is minus is because in the reaction rate it is minus. Okay, so minus P by 3 into x, and this is P into x. Next, EI is constant throughout. This is EI and this is also EI. Then dou m by dou p. So again same thing here, dou m by dou p. So dou m by dou p. So there is p in it. Okay. So dou p will cancel. Okay. Dou p will cancel. You're left with minus x by 3. Similarly, in this portion, there is dou p x by dou p. So dou p will cancel. So you're only left with x. So you've written this value x. So now apply the Castigliano's theorem and find the deflection at C, point C. So delta C is equal to 0 to L m over EI dou m by dou p into dx. Okay. So now because we've split this into two parts, so we'll consider this as usual. So 0 to 12, 0 to 12 instead of m, put the value of m here, minus p by 3 into x over ei into dou m by dou p. Dou m by dou p is minus x by 3 into dx plus the next part, next equation, that is next portion here, that is to 0 to 4. Limit is 0 to 4, so 0 to 4. M is px over ei into only this, dou m by dou p, that is x into dx. So now let's solve this. So p is common here, so p by 9 ei, I'll take it common, p by 9, minus into minus becomes plus, so it is x square into dx plus, again same thing, p over ei common, 0 to 4 x square into dx. So now p over 9 ei is equal to x cube by 3, 0 to 12 plus p over ei x cube by 3, 0 to 4. Okay, so keep on solving this like this only. So p over 27 ei x cube, so 12 cube plus p over 3ei instead of x 4 cube. So we'll get 64p over ei plus 21.33p over ei. Now that, okay, add both of this, so it is 85.33p over ei. So now that you know the value of p, substitute the value of p. So 85.33 instead of p, it is into 6 over ei, which is 512 over ei. So delta c is 512 over ei. Now this is the deflection at C, that is delta C deflection at C. Similarly, you have to calculate the rotation at A. Okay, so rotation at A is theta A. Now to calculate theta A, there is no load acting here. There is no moment also acting. So what you have to do here, if you want to calculate theta A, you have to apply a dummy moment at A. Whichever point, whatever parameter you want to calculate and whichever point you want to calculate, in case if there is no load or no moment, you have to put a dummy load or a dummy moment at that point. Okay, so now let us calculate the slope at A. Now we have to calculate the slope at A in this portion. Apply a dummy moment P at A because you're finding theta A. So I'll apply a dummy moment. So dummy moment is nothing but P. You can see here there's only P here. Okay, then as usual, okay, now this time because you're taking P here, you consider this load as 6. Okay, now we're interested in theta A. So theta A will be replaced with dummy load P, and this will be taken as usual. So let's find the moment at, okay, now if I find moment at A, I'll not get RA here. Okay, so what I'll do is, my main interest is when I cut this section, left side there should be RA. What I'll do, I'll find the moment at B. So if I find the moment at B, so it is moment at B, so RA clockwise, so RA into 12 plus 6 into 4, okay, second load. Next, this moment is acting anti-clockwise, so moment is acting anti-clockwise, so it will take it as minus. Okay, so I'll take it minus. Again, this the idea of drawing this moment is, in AB span, if there is a load acting, try to push the beam downward. To stop this, this moment will act upward. It will push it back. So I've shown this like this. Okay, anti-clockwise. So RA into 12. Then this is anti-clockwise moment minus plus 6 into 4. Okay, 6 into 4 is equal to 0. So solve this and you'll get 12 RA minus P plus 24 is equal to 0. Again, you don't know the value of RA, so keep it as it is. So it is now RA is P by 12 minus 24. Okay, P minus 24 divided by 12. You can either keep it like this or like this. The choice is yours. Both mean the same. So this is nothing but P by 12 minus 2. 24 divided by 12 is 2. Okay, now let's calculate the moment at section XX. Again, we'll draw the table portion. Now the reactions are different here. Okay, so things will change. Now calculate the moment, bending moment at XX. So calculate the bending moment at XX. So left side, there is only one load here. Okay, and in portion AB, as usual, AB, BC, portion origin is A here, origin is C, limit 0 to 12, 0 to 4. Okay, so we'll calculate the moments now. So this is the reaction, that is P by 12 minus 2. If this is confusing, you can always use this. So P minus 24 divided by 12 into this distance, into X. So into X, and there is a load here, external moment here, dummy moment, that is, it's anti-clockwise, so minus P. Similarly in BC, to the right side, again 6 into X. It is only 6 into X. Now you have to differentiate this dou M with respect to dou P. So dou M with respect to dou P. So there is P in it here. So this dou P by 12. Okay, it is like this, dou P by dou P divided by 12 into dou P. So this dou P will cancel. So you're left with this X. So if you multiply this, it is X by 12. Okay, so it's dou Px by 12 minus 2x minus P. So it is now dou Px divided by 12. So dou P will cancel. So you're left with only X by 12 minus dou P by dou P is 1. So written 1. So here there is no P in it. Okay, so dou P by dou P. Here there is no P, so it becomes 0. Differentiate, you cannot differentiate because there is no P. Alright, so now theta A, again theta is given by 0 to L complete. Write the formula first. 0 to L M over EI dou M by dou P. So 0 to 12. Again, now put this value. P minus 24. P minus 24 divided by 12 into X minus P into dou M by dou P is this parameter, X by 12 minus 1 is equal to 0. So now put P is equal to 0 for dummy moment. Okay, put the value of P. P is equal to 0 for dummy moment. So strike off this. And then simply you need to calculate extra. So this would be 24 divided by 12 into X minus 24 divided by 12 into X. Then P is 0, X by 12 minus 1. So theta is now 1 over EI, 0 to 12. This is X. Okay. So this is now it becomes, multiply this, X square divided by 6. 12 ones are 12 twos are 2 ones are 2 6 are. So X square divided by 6 plus 2 into X. Okay. So plus becomes minus plus 2 into X. So 1 over EI, X cube by square it. Okay, so it becomes X cube by 18 plus 2. 6 is out actually, so 6 into 2. 6 3s are 18. Okay, so 2 X square by 2, 0 to 12. So 1 over EI, 12 cube over 18 plus 12 square. So when you solve this, you'll get theta is 48 over EI. Okay. This is also on the same lines. Find the deflection under the load point. E is equal to, in this they have given you the value of E and I. They have given you the value of E and I. So in this E and I, it's already, no need to simplify this as such because kilonewton, it is in kilonewton and meter. Kilonewton meter, this is also in meter raised to 4. So you can use this value directly, E and I. If you multiply this, you'll get the value of EI. Okay, now see here, find the reflection at the load point. That means you have to find deflection at this point, C. Okay, then as usual, first at C there is already a load. So what you do, because there is already a load, you cannot take dummy load here. So put P is equal to 50 kilonewton. And once you put P is equal to 50 kilonewton, find this reaction, find the moment about A. So this is RB into 7, then P into 3. Okay, so RB is 3P by 7. RB is 3P by 7. Next reaction, RA plus RB is equal to P. So RA is equal to P minus 37 by P. So RA is equal to 4P by 7. Okay, once you find the reactions RA and RB, then as usual, use the table. Portion AC, BC. Okay, Origin for AC is A, origin for BC is B. So the limits is 0 to 3, 0 to 4. Okay, then moment. So left side, in portion AC, cut this section, left side. So it is 4p by 7 into x. 4p by x into 7. Next, to the right, when you cut the section BC, it is 3p by 7 into x. Okay. Next, EI is constant throughout. Then differentiate this. Okay, differentiate moment with respect to p. So it is 4px by 7. So dou p by dou p. So cancel both the terms. Dou p by dou p. So you're left with 4x by 7. Similarly, here also you're left with 3x by 7. So again, use calculate the deflection at point C using Castigliano's theorem. So it is 0 to L m over EI dou m by dou p into dx. So it is 0 to 3. Instead of m, put the value of m here, m over EI into dou m by dou p, this value. Similarly, like 0 to 4, moment 3px by 7, 3x by 7 into dx. Then solve this. So you'll get this, once you solve this, 4 4 is 16p over 49 EI, 7 7 is 49, x square dx plus 3 3 is 9, 7 7 is 49 over EI, x square by dx. This is 16p over 49, substitute, integrate this, x cube by 3 is also x cube by 3. So once you solve this, you'll get 2.94, 3.92. Now add both of these. Now when you add both of this, you'll get a value, and once you get the value, then substitute the value of P here. So P is 50 kilonewton. Okay, put the value of P divided by EI. Now you already know the value of EI. Substitute E 2 into 10 to the power 8, I 4 into 10 to the power minus 6. So in solve this, you'll get delta. Delta C is equal to 0.1225 meter. So answer is positive. That means the deflection is downward. Okay. Similarly, the next type of problem here is find the deflection under the load point. So here the load point is this portion. See, it is now again the EI value is different. To AC it is I, up to BD it is I, and CD it is 2I. So it is 2 meter and CD is 4 meter, and again it is 2 meter. Okay. So here they've asked you to find EI is given kilonewton meter square mm square, and it is here also it is given mm square. So you have to convert this into meter square. Okay, so as usual, first find the reaction. So it is 60. Reaction is RA, 30 and 30. This is exactly acting at the center. No matter of this IEI value, just find out the reactions was 30, 30. Okay, now due to the symmetry, I'll name this point here below the point load. I'll name this point as E. Okay, so in this question I've shown it here. Okay, so at E I have to find the deflection delta E. So again I'll check the loads here to the left and right. Okay, so what I'll do is I'll split it this. I'll take only left side portions. So AE up to AE. So AE has AC span and CE span. Okay, so the portion AC first, portion AC, then portion CE, this portion. Okay, origin of AC is A, origin of CE is C, this portion. Because I'm just cutting the section here. So origin remains this. Okay, it's not a complete beam. If it was a complete beam, then origin beam would be this end. That is origin C. Okay, then I'll cut this portion here. Then I'll find the limits. 0 to, in AC is 0 to 2. CE is 2 to 4. Then I'll find the moments. So I'll cut this section here. Left side moments. So left side moments is, now here what I've done here is instead of 60, I'll put this 60 as P. So if P load is acting downward, to stop that, there is P by 2 acting upward on either side. So I have shown it here. P is acting down. To stop that, P by 2, left side, right side. And then why I'm substituting with this value P is because according to Castigliano's theorem, it should be the reactions and all should be with respect to P, so that we can differentiate it later. Okay, so now I'll take this left side, only one reaction, that is P by 2 into complete X. So P by 2 into X. Similarly, when I cut this section in CE, okay, so it is P by 2. Okay, you can see it, P by 2. Now I want, in CE I have cut the section, so I want only this distance. So if you want to find this distance, okay, so I'll take the complete length. So complete length is 2 plus 2, 4. It is 4 minus x distance. 4 minus x. So it is P by 2, 4 minus x. Okay, then EI value. Now EI value in AC is EI, but in CE it is 2 EI. So I have to put this here accordingly, 2 EI. Then dou m by dou p. So dou m by dou p will cancel. So I left with x by 2. Here also dou p will cancel. So I left with 4 minus x by 2. Okay, as usual. Then find the reflection at E. Apply the Castigliano's theorem. So again, if you apply the Castigliano's theorem, complete for AE. So this is only for span AE. So it is equal to, again as usual, 0 to L m over EI dou m by dou p. So now we'll split this into two parts. So first part is AC. So 0 to 2 m over EI. M is P by 2 into x over x by 2 into dx plus this portion, and that is 2 to 4, 2 to 4 m into dou m by dou p. So substitute this value, and care should be taken that at this portion here it is m over ei, you put this m over ei, but here it is 2 ei, so it is m over 2 ei into this value. So when you solve this, so it is p over ei x into x square into dx plus, okay, again multiply this. So take this p, 2 comes down, so 2 2s are 4, 4 2s are 8, so 1 over 8 ei, so 2 to 4. Now limits are in a CE span is 2 to 4. Multiply these two brackets. Okay, so again solve this. Okay, now important thing here is multiplication. So this is 16p minus 4px. You multiply this, minus 4px plus px square. You can add this, so it becomes 16p. Both are same, minus 8px plus px, or you can do it like this. Next step, you can just substitute the values here. So it is now p over ei, x cube becomes 0 to 2, so 2 cube divided by 3 plus 1 over 8 ei. So 16p, instead of x, I'll substitute the value 4 minus 2. X is nothing but 4 minus 2. Here also x square is 4 square minus 2 square. Again same, 4 square minus 2 square. In this cube, in this is p by 3 common. Instead of x cube, I'll write it as 4 cube by 2 cube. So again, when you solve this, you'll get this answer. Then now that you know the value of p here, solve this continuously. Now that you know the value of p, so p is nothing but, say we have got minus 3.66p. So p is 60 kilonewton. Substitute the value here, 60 kilonewton divided by ei. Substitute the value of ei, though it is here in mm square. Convert this and substitute the value, and you'll get the answer, minus 0.1098 meter. So the answer is minus, that means deflection is upward. Okay, that's all for today. Thank you.